Hi everyone, in this problem we'll be looking at a figure based on geometry. Two similar semicircles and one quadrant are drawn inside a square of side 14 cm. Find the total area of the shaded parts, and we have to take pi as 22/7. Okay, so they state that there are two similar semicircles and one quadrant. The two semicircles that they state are this and this. As you can see, they are both overlapping in this region. This is the region of overlapping. I've drawn the figure here, so I'll just show it here. This is one semicircle. This is another semicircle. They're overlapping over here. And also one quadrant is drawn inside. This is the quadrant. Now they want us to find the total area of the shaded parts. Okay, so first let's label the shaded parts. Let's have this shaded region as Y and this shaded region as X. So we can mark it here. I've brought different sketch pens so we can differentiate it easily. This is X, this is Y. What is Y again? Y is this part. So when you divide into parts like this, it will be easier for you to not get confused by the diagram. Okay, so this is Y and this part is X. Okay, so we have to find the total area of X and Y. How do we find it out? Okay, first we know that this is a quadrant and we know that this is a semicircle and we know that this is also a semicircle. So let's find out the known figures first. What's the area of a quadrant? Area of quadrant is given as pi r square by 4. And what's the radius in this case? It is 14/2 and that is 7. So we have pi r square by 4 and that gives 22/7 into 1/4 into 7 into 7 and that is 38.5 cm square. Now we are going to write down all the data here because it could get kind of confusing. Area of quadrant 38.5 cm square. Now let's find another known figure and that is this whole square. Whole square will be given as 14 into 14 and that gives 196. So the area of square will be 196 cm square. Okay, so we found out the area of the square and the quadrant. Next, how do we proceed from here? Look at the figure. To usually find the unshaded part is not any particular figure, so we can't use a formula to find it out. So what we have to do is we have to eliminate a known figure from it. So to find the shaded part we have to eliminate the unshaded part. Okay, so let's focus on this figure, this semicircle, and let's find out this region X. How do we find out this region X? First, let's actually draw it out. Let's enlarge it and draw it out. This is a semicircle. I'm drawing out this part. It has X like this. This is because of the other semicircle overlapping it. This is X. This is 14, so this will give 7. Okay, and this is the shaded part. Now, how do we find out this region X? We know that this is a quadrant. Can we make this into a triangle? Like this, dividing it like this. We can make this into a triangle, right? We can find out the area of the triangle. What is the area of the triangle? Half into base into height. Base and height are both 7. So this will give 24.5 cm square. This is the area of this triangle. We know the area of the quadrant, so we can find out this region. Right? We can find this region out. We know this area, triangle area, we know the area of the quadrant, so this region can be found out. Area of quadrant is 38.5 minus 24.5. This gives us 14 cm square. Now what is 14? 14 cm square is half of this. It's only half of this, because this is the triangle, this is the quadrant. We have only found out this region, not this region. So to find out the total shaded area, we can take 14 into 2, that is 28 cm square. I hope that you are following me. Now we found out the area of x. What's the area of x? 28 cm square. Okay, next, so we have found out one shaded region. Now comes the big shaded region, and that is area of y. What is y? Y is this shaded region. We have found this out. Now we have this shaded region. Now to find this, we have to ignore everything else that we have found until now. Okay, let's look at the diagram with a different perspective. Ignoring this shaded part, let's look at all of the white parts including x. If you look at it carefully, the figure will actually consist of a semicircle, one quadrant, two quadrant, and an extra bit. Let me say it again. It consists of this quadrant, one quadrant, plus, isn't this another quadrant? Another quadrant, a whole semicircle, plus, what have we left out? Is that all? We have left this part out. This is a white part. Let's have this as extra piece. I'm naming this part as extra piece. Rest of it, one quadrant, quadrant, semicircle, they all give the area of a full circle. Right? Now I've taken this also into consideration, part x, because we are done with x. We have found out the area of x. Now our only goal is to find out the area of y. So everything other than y should be taken into account. Only then we can subtract everything else from this square area and find out y. So let's now go ahead and find out what this equation is. So 1 quadrant plus 1 quadrant plus 1 semicircle. What does that amount to? That's actually 1 circle. What's the area of the circle? Pi r square. That is pi into 7 into 7. 7 into 7. This gives us 154 cm square. So now we have the area of circle. 154 cm square. Now we have one last thing to find out, that is the extra piece. Now what is the extra piece? Let's look at the diagram. What's the extra piece made up of? The extra piece is nothing but this quadrant. I'll just mark it with the sketch. This quadrant, subtract this region x. the quadrant minus region X will give extra piece. So extra piece will be quadrant area minus X. Quadrant is 38.5. X and X is 28. So this gives us 10.5. 10.5 cm square is the area of the extra piece. Now that we have found out the area of the extra piece is 10.5, and we have the area of the circle, which is 154. If we subtract both of this from 196, which is the area of the square, what is the area of the whole square? Area of the whole square is 196, 14 to 14. So we are subtracting the area of the extra bit, this part, plus this circle. We get what? Region Y. We'll get region Y by solving this. Okay, so on solving this, we will get 31.5. Now what's 31.5? Y region. What is the total region of shaded part? X plus Y. So don't forget that it's not just Y, it's X plus Y, and that is 31.5 plus 28. 28 is the area of X. Totally it gives us 59.5. Okay, so I agree that this is kind of a difficult problem, but the key to solving such a problem is to break it down piece by piece. The first thing that I've done is I found out the known figures of all of the known figures that are given in this problem. So we have the area of the square, we have the area of the quadrants, and then we found out this shaded part by taking two known figures, that is quadrant and triangle. We have found out X, and we go about in a systematic manner like this. After that, we look at the bigger picture. We realize that the shaded part is made up of a circle and some extra bit. We find out the extra bit area, and then we subtract to get Y. So this is how you solve such a problem. Thank you.